That thing had 9 lives. She just spent them all. Woo!
Well, here we are again. Same brand, different location. We had an E5 error, or we have an E5 error, and I checked the inverter board with the inverter board tester. It tested good. I checked the voltage coming off each lead to each other, and they were reading the exact same voltage across all 3 leads. If you have greater than 5 volts across, like from one leg to the other leg, that's a sign of a bad inverter board. So we don't have a bad inverter board. I meg-ohmed the compressor. It megged out okay. When I first measured the voltage DC across here, across the white and the black wire, from what I was getting the reading the first time, I checked the pressure. It's right there. Sunshine blindness here, and I could have swore it was reading off, so I went ahead and put a new one in temporarily right there. It's off the same line, but my compressor kept going. It would get up to 17 amps, and a locked rotor is like, I don't know, 70. I mean, it wasn't locked rotor amps. I mean, normally they'll run up to 20 amps, and then they'll have an L8 error. But it would ramp up to 17. It sounded okay, no bearing noise or anything. And then it would wind down to about 5. Then it would wind down to 0, and it'd wait. Meanwhile, and this is the master side, the slave side would run. It would go back up again, probably around 8 amps, and then kind of wind back down. So I was worried that after I had done the voltage test on this, and I got the exact same voltage across all 3 leads, the next step is replace the compressor. So I went ahead and called a technician at the company that deals with these, that sells us the equipment, and they also service it. And there's one of the technicians there that's really knowledgeable, and he's seen a lot more of this stuff than I have in different locations. And I gave him told him what I had checked, and he told me, he says, if that thing's ramping up and then ramping back down, and I hadn't told him it was doing that yet, and he says normally if they ramp up and ramp down and do that a couple times, and he gave me the amp draw, and he was like right on the money on the amp draw. He says your compressor's shot. So this one's never had a compressor yet, so we are here to replace the master inverter on an REMQ 120 PBTJ, and right now we got it in recovery mode. The new protocol for recovering these, instead of just closing the valves and pumping it into the system, the company that sells us this stuff and servicing it, apparently they've been having a lot of callbacks on compressors and losing compressors here and there. So the new protocol that they're following is they're recovering all the charge. So I got 48 pounds on this thing, so I got to recover all the charge. So I don't have to shut any valves off, but I'm going to recover from both suction lines on each system. It's the biggest line, and all the valves are open. That's what recovery mode does. So I got to get this set up, get that one open, get the field piece on there, and start winding it down. And another note, I went back to my SE640 because my amp probe has 2 limitations, and the second one just kind of broke the camel's back, so to speak. I like this thing because it had the 3-phase function on it, but I went to test resistance on, oh doggone it, one of my sensors, oh, my temperature sensor, the discharge pipe sensor. And they're supposed to, it was at the temperature that it was outside, it was supposed to read about 579 kiloohms. This thing read open line, wouldn't read anything. I thought, you know, there's no way it can be bad, so we heated it up with a heat gun, and just to see what it would do, because you got lower resistance the more heat there is. It actually started reading like 61K. Well, I got my Fluke 87 out because I thought that's, you know, the Cadillac of what I have. So I went ahead and got it, brought it up here, and I measured it, and I was reading you know, whatever the temperature was and the resistance was supposed to be. It was like, at the time, let's say 390 kiloohms. So I got to looking on the specs on this thing here, and it only goes up to 60,000 ohms. So it wasn't faulty, it's just limited. I just went to read the the voltage DC on this plug here, and it read 0. And I had the leads on there, I had them buried on there, and it just wouldn't read. It started creeping up, it got up to 1. So it tried to read it, and on the suction pressure sensor, it didn't read anything. Brought my field piece up here, boom, 1.161 volts. I got 2.6 or 2.1 on the suction side, and there's a graph that you got to read for that. And the graph is kind of hard to read because the numbers are like, they go from like increments of like 25. I mean, it's not tight. You might have 45 on one line, you might have 140 or 75 on one line, 145 on the next line. So it's kind of one of those, you just gotta ballpark it. So I had changed that, thinking it was bad, and it wasn't. Apparently I must have just read it wrong. So the good thing is, now that I'm recovering this out, I was going to go ahead and debraze that one and put that one in, but I don't have to do that now, so that's one less thing. Read your specs on what you're going to do. If you're going to do a lot of work on the equipment like this, you need to get good resistance readings and stuff. Most of your other stuff's going to read it. Their ACD 14 clamp meter has that range and that capability. The field piece has it. The Testo clamp meter, I can't remember the number, I think it's the 770-3. It'll do it. Just make sure you read what your limitations are on your meter. I mean, there's flukes that won't read the resistance that high. There's flukes that won't read capacitance below 10, you know, 10 microfarads. So just make sure before you get out in the field and you rely on something, you make double sure on everything that you're going to do. It'll be covered, you know, either by the meter that you're going to choose, or at least you have a backup meter that will do what you've got to do. You know, you never have enough meters, so you just don't have enough money. But anyway, I'm going to get to this. I'm going to get this guy in recovery mode, and I'll get a little more footage if I can. One of the things you'll have to do when you are changing a compressor is take the blanket off. You'll have to take this guy off. Normally they're taped on one side. Once you put them back on, you'll have to use a zip tie. But you don't want to cook this thing when you're putting a new compressor in. Common sense to some. There's a little retainer. Get him out of the way. Try to push him down from the top so it's pulling on the wires. Drop your pliers about 5 times. There he is. Good shape. Set him out of the way. Once we get it recovered, we'll kill the power and take the terminals off. They are still hot. This is more of a sound blanket than anything. These things get brittle, so. Get this guy out of the way. Set him aside. crankcase heater, I always take it off and set it aside. Factory. Bent up. There we go. I put him back on, he'll be alright. Hang him over here. You have bolts to take out on the bottom. You got 3 of them. Small ratchet's always good. It's always good to take this stuff off too and get it out of the way when you're brazing in, because you're going to cook it if you don't. So I got the core removals out. I got it in here, ready to go on both suction lines. So I got to get my recovery machine set up, and I got to get it set up where I can run a water hose on the tank, or it'll just heat up. We used the molecular transformator and it just wouldn't do it. So the other day it just kind of failed on us. The other day the transformator, it just didn't take the heat out of the refrigerant. We had it nice, ice and water mixed, and it just heated up. Got the tank too hot, so we ended up putting a water hose on a slow trickle and got the groundwater so cool right now that it cools down no time. Got the head pressure down to like 275. So let me get that all set up and ready to go. Got the recovery tank set up. Got my water trickling over my tank. I'll try and I'm gonna get the ground wire loose. We're gonna have to take these bolts out, snip some of those wires, and we're brazing that in. This one's brazing fine, and once you get ready for that top braze, if you drop this panel down, it'll do a lot better. So let me get to that, get some of this stuff clip free and everything. Alright, I got the insulation off the piping, got the wires moved back. Before we do any brazing, the wires will be secured with zip ties. Got the bolts out of the bottom. Got a little zip tie on here to help us in some cooling the tank. Still holding about 300, so I'm happy with that. So now it's just wait and fill. What I intend to do is I'm going to get this down to about 1 psi. And I'm going to shut the line that's manifolded to the other unit, which will isolate it from this side. I'll leave this side open. Then I'm going to shut all 3 of these valves, and that'll isolate this condenser from the system. And I'll have vapor, just a little bit of vapor left in the whole system. Once I shut all these valves, I'm isolating this condenser, then I can cut out this compressor, replace it, and then go ahead and evacuate. I'll just be evacuating this condenser. The rest of it will have refrigerant in it, like 1 pound pressure. So I was going to do the whole system. I thought it's kind of silly to do that. It'd be much easier to go ahead and get most of the charge out, and then go ahead and do it the way I just said. So we're about there. It's down to 7. Alright, it's time to cut this guy loose. Let's see if I can get the old CTC in there. This one's going to be a little harder to do. There we go. Come on now. You can cut below the bell. You cut above the bell, you're screwed. So. Did not get all the way through. Got most of the way through. And I got a cut down here on this one. Got the pressure relieved right here. Oil's got pressure in it. It just kind of stays in there. It's always just easier just to cut these out. You can use a Sawzall if you needed to, because your compressor obviously isn't going to be used. And the piece of pipe that you're going to take off of here is going to be debrazed, so you're not going to have any jagged edges. And normally what I do is once I get it off of here, I will put a little paste flux on the joints, put the pipe in there, and it really takes the brazing rod, the 15%, really good. Helps suck it into the joint a little better. It's not a necessity, it's just something I like to do. Don't put a lot in there, just a little bit. Then on this one here, I will have to put, right about there, I'll have to put a 3/16 access stub, because if I don't, even with that open, when I'm brazing right here, normally it just gets pinholes because there's a little bit of pressure, it stays on there. So that's what we do. You gotta be a little careful when this pops loose. Sometimes there's isolated pressure in here. Out goes the weasel. Alright, let me finish this up with the other imp that I have and get this compressor out. SSTs, and take the core out, because when you're brazing this top joint right here, you got pressure in there from the refrigerant in the system that's still in there, that's boiling off the regulator. So you put that in there, you don't get any pinhole leaks right here. Usually what I do is I'll hit this one first, hit that joint, and then I'll hit that one. Now it's all cooled down. I'm going to go ahead and put the core in there and the cap. It's always easier to drop the panel after you get the bottom one in. You take the panel out, and then you've got free access over here to get to the top one. Try to do it without that panel out of the way, and you're just shooting yourself in the foot. It can be done, but it's a pain in the butt. So we're gonna get the panel back up and get this together and put it on a vacuum. Even though it's a pain to have to put this service port in here in order to braze because of the pressure, the good thing is it's always got constant refrigerant in there, and you still have to evacuate it. Listen, see if you can hear this. Still has a little bit of pressure on it. So there you go. You know, the system's got pressure, vapor in it. It keeps it from, you know, instead of having to braze, purge nitrogen through here, you've got that constant refrigerant that's going through there. So you can get your brazes in and you're good to go. You just have to bleed the pressure off before you evacuate the system. That's the only bad thing, you know. But, all right. Let me get this thing set up for evacuation, and we're going to put it on a pump down. And one little tip or piece of advice: if you had, you know, you're going to have to clip a lot of wire ties in order to get these wires extended so you can go ahead and drop the panel, put them back. You know, I mean, it's a pain in the butt step to have to do. Put them back and then clip the ends off, you know. Try to tighten it back up the best you can. You know, they had it there for a reason, and just try to get them back like that again. Now this bad boy here, he's mine. I put him there, so I need to clip him, get rid of him, and then zip tie him to this right here. So get one more zip tie in, and on the pump it goes. Power's been killed, so I'm going to have my partner Keith turn on the power. And now I'm going to put it in evacuation mode again. 21 times in mode setting 2. So now all the valves are opening up on everywhere, but now the whole condenser's opened up so we can evacuate. Shouldn't be too bad considering there is pressure on the system. We just have to relieve it, and then we're gonna put the pump on here and give the old vacuum. We may have to evacuate for an hour because the microns sometimes keep going, just kind of stay like around, I don't know, they never really get down. Sometimes we'll get to 480 or making some weird sounds here. But sometimes they never get down to good microns because of refrigerant, so let's get to it. I got the vacuum hoses on the manifold line, which is open to the system and closed to the other side. It's open to this condenser only. And then there's a charging port. It's only on this, on this system only. It's isolated from everything else. We have 1.9 pounds. So I'm gonna have to bleed that out through the refrigerant hose. Got a 3/8 hose with a 1/4 inch 45. It's always a got that on. Gotta take it off the pump because we gotta bleed the pressure off first. Got it open up, bleeding the pressure off. In there. Still got the fancy schmancy handle we made. Alright, about lunchtime. Let this bad dog do its job. Get some stuff done, go to lunch, come back. Hopefully, sometimes we get microns, depends on how warm it is outside. If it's warm enough to start kicking out the refrigerant, it's bled most of it out, will be good. But we only got 2 brazes, so, and they're good. Guarantee it. Alright, be back. That's not too bad, considering we normally don't get a micron reading on these because of the bleeding off refrigerant, so I'll take that. Alright, I'm going to shut this down and valve it off and put the refrigerant in it. Right, now I've got all the stop valves opened up. Open that one up there. Gonna get the caps on there. Time to dump in the charge. Hopefully we can get most of it all in there. If not, we'll have to go into auto charge mode. Looked out the other day, I got 63 pounds in a unit. Didn't have to put it in charge mode, so. New field piece, SRS1. So, got all this back together. Got all the electrical together when it was off the first time. Gonna get the blanket back on there and let it charge up. Alright, let me get to it. All the covers are on, the charge has been released, and it is running. No goofy compressor action. It is running. It has not faulted out. Calling this one done, son. Take little MV2 home. Thanks for watching.